Hello again. In this video, we're going to continue to look at solving linear systems, or working with two linear equations at the same time, and trying to find the common solution, which is the value for x and y that would work in not just one, but both of the equations for our system. Previously, we've shown you two ways with algebra, using substitution or using elimination, and those two methods could help us step by step figure out what the common solution is. But if you'll recall from a week ago, we used to provide you with the graph of the linear system, and once you had the graph of the two lines, all you needed to do was find where those two lines cross each other, and that coordinate for x and y would tell you the common solution. So if I'm provided with two linear equations like we see in this blue linear system, or like we also see in this red linear system, one option for solving it is to go ahead and make a graph with the two lines there. We're going to look at the blue linear system first, and you should notice that both equations in the blue linear system are what we would call slope-intercept form equations. By that we mean they both are saying y equals some number times x plus or minus some number. Y equals some number, 1 times x, plus or minus some number. We like to see linear equations in this form because it's quick and easy to graph. As you'll recall, we only need to have 2 points to graph a straight line. And when it's in slope-intercept form, the b, or this number that's added or subtracted by itself at the end, tells us the y-intercept. When I make x into 0, y is going to have to be a positive 5. So for this first blue linear equation, I graph the first point. And then I'm going to use the slope, which is the coefficient that's multiplied with x, to figure out where the second point would be on this line. A slope of -2 really means -2 over 1. And if we recall, slope means rise over run, or -2 over 1 means I would go down by 2 from this y-intercept and right by 1. The line would continue to follow that down by 2, right by 1 pattern, down by 2, right by 1 pattern forever and ever, because that rate of change is constant. We'll go ahead and draw a straight line through those 2 points that we just made. And now we have a graph for that first linear equation in the blue linear system. Similarly, we would go ahead and for that second linear equation, we're going to put a y-intercept of -4. And then we would use the slope, after we've plotted this y-intercept here, we would use the slope, which is really a 1x, meaning 1 over 1, or every time I go up by 1, this line also needs to move right by 1. We keep going up by 1 and right by 1, so we'll go ahead and do that twice. Up 2, right 2 is the same ratio as up 1, right 1. We draw a line through our 2 points. And what we're looking for here is the common solution, or at what point on the graph do these two lines from our linear system cross each other. And now we can see right here where x is at 3 and y is at 1, these two lines hit, which means if I plug in a 3 for x and a 1 for y, both of these equations would end up being true. Now, graphing the red linear system is a little more difficult. You may notice these equations are not in slope-intercept form. They do not just say y equals the slope times x plus the y-intercept. It's more difficult to tell by looking at these equations what the y-intercept would be, and it's much more difficult to tell what the slope would be. But we do have a strategy that can help us quickly graph these. When we see two equations that are not in slope-intercept form, I'm just going to go ahead and figure out 2 points on these lines, what their y-intercept is and what their x-intercept is. The reason for that is these are the two easiest points to find. To get the y-intercept, I'll plug in a 0 for x. So if I change this x into 0, the only thing remaining is y equals 7. So I know when x is 0, y would have to be 7 according to this first equation. So if x is 0, y is 7. And then I can find the x-intercept, where this red line is going to hit the x-axis, by making the y into 0. And if y is 0 in that first equation, that tells me the x is going to have to be 7, so 7 equals 7. I go ahead, x is 0, y is 7, and that point has been plotted for us. We would go ahead and connect those two lines. Sorry, make a line that connects those two dots. And now we've graphed that first line, even though it was not in slope-intercept form, by just finding 2 points. We would need to do the same thing for the second equation. To get the y-intercept, we're going to turn x into 0, which would eliminate the entire 2x term. And I know half of 8 is what makes 4. And a negative times a negative would leave a positive. So I know if I make x 0, y is going to have to be negative 8 because half of 8 is 4 and a negative times a negative is a positive. So if x is 0, y has to be negative 8 for that second equation. Similarly, if I look now at that second equation, I need to go ahead and figure out what the x-intercept is. I figure that out by making y equal to 0. When y is equal to 0, this whole negative 1/2 y term disappears, and I'm left with 2x equals 4. 2 is a number that when I multiply it by 2 equals 4. So if I make y 0, the only value for x that can work is 2. So when y is 0, when I don't go up or down, x has to be at 2. I plot that point there. I have 2 red dots now for the second red equation. So I'm going to go ahead and connect those 2 points. When I connect those 2 points, there we go, we see where these 2 lines cross each other. They cross each other right here at this point when x is 3 and y is 4. So now I've graphed these 2 linear equations down here, and I've realized their common solution must be the value x is 3 and y is 4.